Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of scatterplots. This is standard 8.11a in the great state of Texas, and we are using item number 11 off the 2016 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got Julie. She's making 25 international long-distance phone calls to London last month. The scatter plot below shows the length and cost of each phone call. All right, so our x-axis is how long the call is. Looks like our shortest is hair under 5 minutes, maybe hair under 6 minutes, maybe 5 minutes. And looks like we're scaling by 3, so that's going to be 27. Looks like maybe 28. So we're ranging anywhere from 28 minutes. So our range here is going to look anywhere from 5 to 28. And then we've got our cost. So our so these dollars, it's not really that much. So this is 50 cents right here. And some of those looks like half of those, okay? So the range in length, and let's see our range in cost. Looks like we're going anywhere from a quarter, wow, all the way up to, this is right underneath that $5, so we're going to call that, so that's your 5 right there. Maybe call it $4.90. So huge range in length and huge range in cost. And so we're looking for the relationship between the two. So A, as the length of call increases, okay, so as we're going to the right, the cost of the call increases, okay? So that would make sense, right? The longer the call, the more money. Like if there's a flat rate of so much money per minute. Well, if you were to do that, you would expect to see a linear relationship. Kind of looks like this, right? That's kind of what that would look like. It would be pretty straight. It might end up curving if there's like a cap or something, but if it's just a per minute rate, it would look like a straight line starting from the origin and moving up to the right, like positive slope. That is definitely not what we see. These dots are all over the place. So I'm not thinking it's A. Let's check B. As the length of call increases, the cost of the call remains the same. All right, well that would look like, so I'm going to label this as my A line. So that might just be like a flat rate, like it costs $3 to call London, and it doesn't matter how long the call is, so it would look like this. Whatever that price is, I just picked $3 out of the air. It would be a flat. As you increase the length of call, the cost remains the same, so your B line would look like this. Obviously, it's not that, because those dots should be near one of those lines, right? And they're not. And then we've got, as the length of the call increases, the cost of the call decreases. First off, that doesn't make sense intuitively. Secondly, it would look something kind of like this, right? It would be, the longer you talk, the less it costs. First, I mean, that just doesn't make sense. And it would look like this, and it doesn't look like that. So these dots are all over the place. We've said it, and it's pretty obvious. Look at D. There is no relationship between the length of a call and a cost of a call. Look at this right here. These two calls are about 5 minutes, but they're at either side of our range. 25 cents. One 5-minute call costs 25 cents. Another 5-minute call costs $4.90. What's the difference? Look up here. You've got a 28-minute call right there that costs about 75 cents. And you got another 28-minute call that costs about $4.75. What's the difference? Maybe daytime, nighttime? It doesn't tell us. But either way, there is no clear relationship between the length of a call and the cost of the call, because these dots do not form any type of trend, any type of thing that looks like a line. So our answer is D.